Welcome. In this video, we're looking at a short practical activity. So this is to do with electrical circuits. Practical activities are usually carried out in a specialized science laboratory. However, scientific thinking isn't restricted just to location alone. The following activity, you will be required to 1. Consider the requirements of several circuits. 2. Design appropriate circuit diagrams. 3. Construct appropriate circuits using an online simulator. 4. Video record the simulator circuit in action for proof of success. And 5. Compile a short solution video. In order to complete this task, you'll need the following resource. We'll be using the FET circuit construction kit, the DC Virtual Lab, and there's a link, and a copy of this link I will include in the comments below this video. Circuit A. The design brief is as follows. To build a circuit with one switch which switches on one light. A nice simple starting point. Circuit diagram, I'm going to complete this one. Here's a basic circuit diagram, and please watch the following circuit test video. Okay, let's get into the FET simulator. So let's assume you've never been to FET before, the website. We'll type in FET and it comes up with fetcolorado.edu. And there's physics simulations, and we're after the electricity, magnets and circuits section. And here's our circuit construction kit DC Virtual Lab. And we play it. Okay, so the first circuit we were after was one that has one switch which switches on one light. So I'll need a battery, need a wire. This is really just drag and attach. Add a switch. It really is very simple to use. And of course, yeah, if you don't like it, you can cut a section. Light bulbs can be a little bit tricky. To make certain we connect to a positive terminal and a negative terminal. We'll stretch this leg. Okay, so here's our circuit. And we can also change it to traditional symbols. So if I go back, here I have a battery, a light globe, one switch, and when I close the switch, the light globe works. There's proof of my circuit design working. So for proof of completing this task, you'd include the following test video. Here I have a battery, a light globe, one switch, and when I close the switch, the light globe works. The rest of these circuits I'll get you to do to design a circuit diagram and to construct a test video. So circuit B uses one switch which switches on two light globes. Circuit C, two switches which switch on two lights. One switch switches on one light globe and the other switch switches on the other light globe. Circuit D, two switches and both need to be pressed to turn on a light. Circuit E, two lights, one stays on all the time and the other can be switched on and off. Circuit F, two switches and three light globes. One switch switches on one light globe and the other switch switches on two different light globes. Circuit G, three switches, and if any one of them is pressed, the light globe turns on. Circuit H, three lights, one stays on all the time, and two can be switched on and off independently of one another. And finally, Circuit I, two switches, two lights, one switch switches on one light globe, and the other switch switches on both light globes. I hope you have a go at all 10 circuits. Try your best and come up with the most creative design you can. I'll be producing a solutions video shortly at the end of this week to put up so you can compare your circuit designs against mine. I hope you enjoy the challenge and do your best. If you've enjoyed this video, please don't forget to like, share, comment and subscribe. And as always, thanks for watching.